In today's tutorial, we will discuss how to bias a PNP transistor. I've come to realize that a lot of people don't understand how a PNP transistor is biased. Now, this is because we are used to the NPN transistor, but in today's tutorial, I will show you how to bias a PNP transistor so that you can as well use it in your electronic circuit design. So let's get started. So here we have a typical PNP transistor, the tip 42C, and you can see the pin configuration, the base, the collector, and the emitter, and you can see the circuit symbol. Now, one thing we should know is that whatever we can do with the NPN transistor, we can as well do something with the PNP transistor. The only thing that differentiates them is how we bias the transistor, and that is what I will teach you in today's tutorial. So if you look at this circuit here, you can see that we used both the PNP transistor and NPN transistor to drive an LED. So the first circuit is a circuit that uses the PNP transistor to drive an LED, and the second circuit is a circuit that uses the NPN transistor to drive an LED. The components we used here and here are basically the same except the transistor itself. So here we use 220 ohms resistor, here we use also 220 ohms resistor, and here an LED and the battery. And if you come here, we'll have 220 ohms resistor, here also 220 ohms resistor, an LED and the battery. But you can see that the configuration of the circuits differ. So that is the difference between the two circuits. The way the circuit is configured for the PNP transistor is different from the NPN transistor. Now I'm going to teach you something very important in transistor biasing, and once you learn that thing, you'll be able to bias both a PNP and an NPN transistor. All right, so here we have two rules which I've stated that will help you understand how to bias a transistor. For today's tutorial, our focus is on the PNP transistor, so it will help you to be able to bias a PNP transistor without having any problems. So number one rule is that you have to understand the direction of current flow through the terminals. All right, so direction of current flow through the terminals, you need to understand that, and you also need to understand the potential difference across terminals. So these two things, once you understand them, the first one is you understanding the direction of current flow, right? And the second one is you understanding potential difference across terminals. So you should be able to understand the direction of current flow in the particular transistor you are working with. So if you are working with an NPN transistor, you should be able to identify how current flows in that transistor. For example, here we have an NPN transistor, and you can see that there's an arrow that indicates the direction of current flow. So this arrow here shows that current flows from the collector down to the emitter, and also current flows from the base down to the emitter. That is what this arrow here shows. So the arrow helps us to understand the direction of current flow in the transistor. So in this NPN transistor, the current from the collector and the base enter the emitter. And in the case of the PNP transistor, you can see that the current from the emitter enter the base and the collector. You can see it. Current from the emitter here, it enters the base and also the emitter. That is why this arrow is facing in this direction. So this helps us to understand the direction of current flow in that transistor. Now that's number one thing you need to know that will enable you understand how a transistor is biased. Now the second thing you need to know is potential drop across terminals. So now we've known that for an NPN transistor, current flows from the collector down to the emitter and also from the base down to the emitter. It means for current to flow from this base down to the emitter, it means that the voltage at the base has to be higher than the voltage at the emitter. Now, this is for NPN transistor, because we know that it is a fact that in a circuit, for current to flow, the potential of the source has to be higher than the potential of the destination. So if current is flowing from the base to the emitter, it means that the voltage at the base has to be higher than the voltage at the emitter. So it's just like saying rain falls downwards. So the potential up is higher than the potential down. So that causes the rain to fall downwards. So for current to flow from the base to the emitter of this transistor, the voltage at the base has to be higher than the voltage at the emitter. The same thing happens with respect to the collector. The voltage at the collector has to be higher than the voltage at the emitter for current to flow from the collector to the emitter. Now this is for NPN transistor. And for PNP transistor, which is our topic of discussion, you can see here that we have the arrow pointing from the emitter to the base and from the emitter to the collector. So this goes to show that for this transistor to conduct, for this transistor to go into conduction, for this transistor to be biased, then current has to flow from the emitter to the base. And for current to flow from the emitter to the base, it means that the potential at the emitter or the voltage at the emitter has to be higher than the voltage at the base. So this is a fact you need to know that will enable you be able to bias a PNP transistor. So if we are to bias a PNP transistor, we must make sure that the voltage at the emitter is higher than the voltage at the base. And for us to bias that transistor to saturation, then the difference between the voltage at the emitter and the voltage at the base has to be at least 0.6 volts. So once the voltage difference between the emitter and the base is 0.6 volts or above, then that transistor can be biased to saturation. So if we look at this circuit here now, this is a typical PNP transistor circuit where a PNP transistor is used as a switch. Now here we have the PNP transistor, we have a current limiting resistor here as R1 and also a current limiting resistor here as R2 and battery as a power source. Now if you look at the circuit, you will agree with me that this 9 volts is connected, the positive terminal of the 9 volts is connected to the emitter. So this emitter here is having 9 volts. And the negative terminal of the battery is connected to the base of the transistor. So this transistor base is getting 0 volts and the emitter is getting 9 volts in this circuit configuration of the PNP transistor. And the collector also is connected to 0 volts. So what this means is that if we check the voltage difference between this emitter here and the base here, the result must be at least 0.6 volts for this transistor to be biased to saturation, for collector current to flow enough to drive this LED. So if you want to bias a PNP transistor, you have to make sure that the voltage at the emitter is higher than the voltage at the base. And in this case, in this example we have here, the voltage at the emitter is 9 volts, while the voltage at the base is 0 volts. That way we were able to bias this transistor, and we had collector current flow in the circuit, which was able to drive our LED. Now let's say you want to bias the transistor, but you don't want to use 0 volts to bias it. It doesn't matter the voltage you want to use to bias the transistor. What matters is let the voltage difference between the emitter and the base be something reasonable, say about 0.6 volts and above. So to realize a circuit whereby we can bias our transistor without using 0 volts, that is for a PNP transistor, we check out this circuit. So this circuit here, we used a voltage divider network to bias the PNP transistor, and at the end of the day we were able to bias the transistor. We had our collector current flow in the circuit, but we did not send 0 volts to the base of the transistor. We sent a voltage that is more than 0 volts to the base of the transistor. However, because of the way the circuit is configured, we had that the difference between the voltage at the emitter and the base is more than 0.6, and that was able to bias this transistor. So with this voltage divider network, we have at R1 12K and R2 we have 1K, and the voltage divider here, if we carry out the calculation, you can see that the voltage drop at R2, which happens to be the base of the transistor, if we do the calculation, you can see that is equal to R2 all over R1 plus R2. And when you do the math, you multiply by 9 volts, which is the source voltage or VCC, and the result will give us approximately 0.69 volts. Now, this is the voltage that we have here. Okay, so if we take into consideration the voltage at the emitter, which is 9 volts, okay, this is 9 volts connected to this emitter. If we subtract that 0.69 from 9 volts, we will have 8.31 volts. And this 8.31 volts is enough to bias our transistor to saturation. And that is how we were able to use this voltage divider network to bias our PNP transistor. So in summary, to bias any transistor, but in our case, we are looking at the PNP transistor. To bias a PNP transistor, in summary, you must understand the direction of current flow. All right, as we have it here, we have to understand the direction of current flow. So in this case, you can see that the current is flowing from the emitter to the base and also from the emitter to the collector. And once you understand the direction of current flow, which the symbol here shows, then the next thing you need to understand is the potential difference between the two terminals. That is the potential difference between the emitter and the base of the transistor. So you must make sure that the voltage or the potential at the source of current flow is greater than the potential or voltage at the destination of current flow. So in this case, the source of current flow is the emitter and the destination of current flow is the base. So because current has to flow from the emitter to the base, then the voltage at the emitter has to be higher than the voltage at the base. And if you want to bias the transistor to saturation, you must make sure that the difference in this voltage or the difference in the potential between the emitter and the base is at least 0.6 volts and above. And that way, you will be able to bias that transistor to saturation, maybe to use it as a switch, maybe for automation or for any other electronic circuit design project. So that is basically how to bias a PNP transistor to use it for your electronic circuit design. I hope you learned something from today's tutorial. If you did, kindly give this video a thumbs up and let us know your thoughts in the comment section. Please subscribe to my channel to support my work. Share this video for others to watch and learn. Thanks for watching and see you in the next tutorial. Until then, keep learning. And again, if there is any topic you want me to treat, let me know in the comment section. I will do my best to do that. Thanks for watching once again and see you in the next tutorial. Until then, keep learning. Bye.